Okay, so as in the last video, we have discussed about the Coulomb's force in the dielectric, alright, and that was equal to F is equal to 1 upon 4 pi epsilon naught into relative permittivity into Q1 Q2 over R square, because we know that when we place a dielectric between the two charges, the Coulomb's force is decreased by 1 upon ER, and ER was the relative permittivity. Alright, in today's video, we're gonna take out the dimension of the Coulomb's constant, and we know that the Coulomb's constant is equal to Newton meter square per Coulomb square. Alright, but before that, let me write the topic here. Today we're gonna drive or take out the dimension of Coulomb's constant, which is not actually the Coulomb's constant K. However, that is actually the constant of Gaussian and Hooke's law, right? Coulomb's constant, and that is also known as electrostatic constant. And we have read about its value as well. That's calculated value was equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Alright, that it was the calculated value of this Coulomb's constant, or you can say electrostatic constant. So wait, let me highlight the topic first, then we're going to take out the dimension of this. Wait. Okay, so now as you can see, we take out the dimension by the help of the units. Alright, and we know that the Coulomb constant unit is Newton meter square per Coulomb square, right? Where we know that Newton is equal to what? We know that Newton is the unit of force, and F is equal to MA, which means N is equal to Newton is equal to kg meter per second square, right? Which means Newton is equal to kilogram into meter per second square, right? Let's put this kg into meter per second square instead of this N, right? So kg meter into second square, up we have meter square remaining, so meter square, and down we have Coulomb square remaining, so Coulomb square. Alright, so wait, let me highlight this again so that it cannot create any confusion, right? Alright, here let me highlight this as well. Okay, so this is perfect. So now let's see what this Coulomb square equals to. We know that Coulomb is equal to ampere into second. Alright, ampere into second. So let's put this ampere into second instead of this Coulomb. Instead of this Coulomb, let's put ampere into second. So we know that kg meter into meter square same upon second square same. Instead of this Coulomb, let's write ampere into second whole square, since we have the square on the Coulomb. Alright, so when we're gonna open this square, what we're gonna get is kg meter. Now see, this square and this one, they're gonna be added because they are multiplying. So this would be 3 upon second. Now see, second square into ampere square, alright, into again second square. So it will gonna be equal to what? kg, wait, kg meter cube upon second power 4, since to this, so we have got 4 power, into ampere square. Now let's write this in the form of a dimension. Alright, wait, let me write this in the form of dimension now. So kg we know that is mass, so mass, meter is the unit of length, so L3, second is the unit of time, so when it will gonna go up, it will gonna have minus sign, so -4, and then ampere means A, it will gonna go up and it will have minus sign 2, so inverse square. So when I'm gonna combine these all, what I'm gonna get is m L3 T minus 4 A minus 2. This is the dimension of Coulomb's constant. Dimension of Coulomb's constant. Coulomb's constant. Alright. So we have taken out the dimension of the Coulomb's constant by the unit, and that the unit we used was Newton meter square per Coulomb square, and the dimension we get in the end is m L cube T minus 4 A minus 2. It is the dimension of what? It is the dimension of the Coulomb's law. So finally we have taken out the dimension, and that is equal to ml3 T minus 4 A minus 2. So this was all for today. In the next video, we're going to discuss about the electric field.